Hello students, this is part 2 and we're continuing with the stereochemistry chapter. So pay very close attention to how you identify whether something is an enantiomer or a diastereomer. And also we're going to introduce a new type of compound here. It looks like it has stereocenters, but it actually is achiral, so that's a special case. So molecules with N, just a number, some number of chiral centers, say 1, 2, or 3, can have up to 2 to the N stereoisomers. So these diastereomers, they're not identical and they're not mirror images, so they're not enantiomers. So what's the relationship? We call them diastereomers. If you look at this compound here, this is a cyclopentane with a bromine and a methyl group. These are both up. The mirror image of this is where they're both down. If I assign the stereochemistry, I get SR, and its enantiomer will be opposite, RS. These are clear enantiomers. What if I had a different compound, though, where I only changed the configuration of one of those stereocenters? So I could have the bromine up, but the methyl back. So then now my stereochemistry, the configuration is SS. If I took the mirror image, I get RR. So these two mirror images, those are definitely enantiomers. But what's the relationship between these guys in the box on the left versus the one on the right? They're diastereomers. So something to notice is that if you have multiple stereocenters, if only one of them is changed and not both, then you have diastereomers. Okay, here's our special case. We have a molecule with a chiral center. Look at this. I have a OH, this is the alcohol, and I have this part of the ring, which has some substituent on it, and I have this other left part of the ring, which doesn't. So these are 1, 2, 3, and there's a hydrogen going back. That's 4 different groups. So there is a stereocenter here, but look at the overall molecule. There's a plane of symmetry. So if I took the mirror image of it, you will find that they are in fact superimposable. So this is a special case where you have chiral centers, but it's achiral. It gets a special name. It's called meso. So the biggest way to spot these guys is look for a plane of symmetry. Okay, if I invert this other center here to get the trans configuration, that will be chiral. That's another tip. If you have it cis and identical on each side, that's meso. But if they're trans, you'll find that you will have chirality to the molecule. And just to let you know, these two, what's their relationship? They have 2 stereocenters, but only one is inverted, so it's a diastereomer. Let's put into perspective what we've learned so far. Overall, we were talking about isomers that have the same molecular formula, but they're different compounds. So we've seen that constitutional isomers can have the same formula, but different connectivity. So here the chlorine is in the 1 position, 1 chlorobutane. Here it's 2 chlorobutane. If they can get different names, but same formula, and different connectivity, those are constitutional isomers. Stereoisomers also have the same formula, same connectivity, but different arrangement in space. So we have enantiomers here. 1 chiral center is inverted. They're mirror images of each other. And you also have diastereomers where they're not mirror images, but you do have those chiral centers. The overall, the molecule is chiral, and the trick is seeing maybe one of 2 stereocenters is inverted, but not both. The other thing I want to throw out there is cis or trans or E or Z. Where does that fall? They have the same connectivity, but different arrangement. They're not mirror images, so they actually fall in the diastereomer category. You guys are going to practice. And what I want you to do is pause this and go through each of these and identify the relationship. Are they identical? Are they enantiomers, etc.? And the biggest tip I can give you is don't let this dash and wedge fool you. Just go back to the basics. You need 4 different groups. If there's a plane of symmetry, it's achiral. So pause, and I'm going to go over this. Okay, the first one ends up being identical. There's a plane of symmetry. If I flip this molecule on its back, I would get to this. This compound is meso. It appears that you do have a stereocenter, 4 different groups, but overall the molecule is meso and achiral. The next one, different connectivity, same number of carbons and H's, 6 carbons, and just different connectivity, so constitutional isomers. The next one, we're looking at this chiral center. Don't let the dash and wedge fool you, because I have 2 identical methyl groups. That's not chiral. I need 4 different groups on an sp3 center. So you could draw a plane of symmetry, but either way, you see there are 2 methyl groups. This is an identical compound to this guy on the right. Let's do the next one. These are diastereomers because you have 2 stereocenters, but only one of them is inverted. This left chlorine is inverted. Both are not inverted, which would have given you enantiomers. This last one, it's helpful to redraw this flat, like this guy. And what you would see is you would have had your cyclohexane ring, and this methyl group is pointed down or back, dashed, and this methyl group is pointed up or wedged. So you would be able to see that there are mirror images of each other, and there's no plane of symmetry. They're trans, and so they're enantiomers. Okay, a few more slides left. What about nitrogen or phosphorus or sulfur as a stereocenter? Because you can actually have 4 different groups, right? Nitrogen can have 3 different types of atoms and a lone pair. So what's interesting is atoms with a lone pair are observed as chiral if they have 4 different groups or 3 different substituents, unless the lone pair can interconvert, as you see with nitrogen. So here's a sp3 tetrahedral nitrogen. Think of this lone pair as a balloon, and you're moving it, pushing it through the center of the nitrogen here. So then now the atoms are planar, trigonal planar, and then you push it out back towards the other side, getting this other tetrahedron. So this interconversion is rapid, very low barrier to interconversion. So you do not isolate out or see those individual enantiomers. It's possible at low temperature you can observe that. So in this case, this is not chiral. We would say this molecule is achiral. However, the barrier of inversion is higher with phosphorus and sulfur, so these compounds are chiral if they have 3 different groups. So this phosphorus molecule shown here, chiral. And the last bit that I want to talk about is something called prochirality. You can start with a compound that has no chirality, but it can give rise to a chiral compound. You guys are going to see this when you start reacting molecules, and you'll be able to predict. Sometimes you do get a specific enantiomer, sometimes you get a mixture of both, which we call a racemic mixture. So here is a ketone. If I add a hydrogen, a hydride from the top face, and just to let you know, we're looking at this, so the oxygen is pointed away from us, this ethyl group is towards us. And so if I added an H from the top, I could get this alcohol, where the OH is now pointed back, and this ethyl is forward. So the H that I added from the top base is this H up top. I can also add it from the bottom to give rise to this enantiomer on the bottom. So this is just something you need to be aware of. You can get enantiomers in reactions. And the other thing, I just asked you to assign R or S to this. It's easier to do this one because the hydrogen is down, or you could think of it as back. And you can look at the top and assign priority. So pause and go ahead and try to do that. And what you see is the O is priority 1, ethyl, then methyl. So this would be clockwise, just looking from the top, and the hydrogen's back or down. And that's R. And the other guy is S. Notice that this is called S with parentheses dash 2 dash butanol. It's the OL because you have this alcohol, and the 2 because the alcohol's in the OH is in the 2 position. This one, parentheses R dash 2 dash butanol. Okay, I'm going to end here, and we will start chapter 6 next.